Demonstration of laws of motion. The basic principles of modern physics. When published in 1687, the three laws were unique in that they used mathematical formulas to explain the natural world. Newton's laws defined. Inertia. Newton's first law of motion. Newton's first law of motion, also known as the law of inertia, states that an object's velocity will not change unless it is acted on an outside force. This means that an object at rest will stay at rest until a force causes it to move. Likewise, an object in motion will stay in motion until a force acts on it and causes its velocity to change. For further thought, why do wheels and tops eventually stop spinning without appearing to be touched by a force? Newton's second law of motion. Newton's second law of motion states that when an object is acted on by an outside force, the strength of the force equals the mass of the object times the resulting acceleration. In other words, the formula to use in calculating force is force equals mass into acceleration. Opposing force such as friction can be added or subtracted from the total to find the amount of force that was really used in a situation. You can demonstrate this principle by dropping a rock or marble and a weighted piece of paper at the same time. They fall at an equal rate. Their acceleration is constant due to the force of gravity acting on them. However, the rock has a much greater force of impact when it hits the ground because of its greater mass. If you drop the two objects into a dish of sand or flour, you can see how different the force of impact for each object was, based on the crater made in the sand by each one. Another way to show this is to push of two toy cars or roller skates of equal mass at the same time, giving one of them a harder push than the other. The mass is equal in both, but the acceleration is greater in the one that you exerted greater force on. Newton's third law of motion. Stated simply, Newton's third law of motion says that for every action there is an equal and opposite reaction. Use a pair of roller skates and a ball to show how this works. What happens when you are standing still in skates and then you throw a ball hard? The force of throwing the ball pushes your skates and you in the other direction.